Welcome everyone. In this tutorial, we'll look at a very common situation, importing a production boat model that isn't completely closed and watertight. As you can see, this is an open poly surface, and we'd like to analyze it in Swordfish. The first step is to clean the model. Remove any blocks, floating surfaces, rigging, and every object that isn't needed for the hydrostatic analysis. The goal is to end up with a model where the entire boat can be selected and running the join command results in a single open poly surface. As you can see, this model still has disconnected parts, open edges, and even a complete hole. This is a very common situation when working with production models. Instead of rebuilding and closing every surface manually, there's a much faster workflow. First, create a mesh using Rhino's default mesh settings and press OK. Next, run the shrink wrap command. Shrink wrap creates a new closed mesh that wraps around the entire model, automatically closing all the gaps and holes. For most boats, I recommend using an edge length of around 15 millimeters, an optimization value of 10%, and the remaining settings as shown. You can also increase the edge length if you want a slightly coarser mesh. In this example, let's use 25 millimeters. Play a little with this value to get a more or less precise mesh. After a few seconds, Rhino generates a new mesh. As you can see, it's now a single closed mesh, while still preserving the overall shape and volume of the boat remarkably well. At this point, we could import the mesh as it is. However, section generation and all subsequent analyses, including hydrostatics, balance, and stability, would be significantly slower. That's why we recommend running reduced mesh first. In most cases, reducing the mesh to around 2,000 to 3,000 polygons is more than enough. A reduction of about 95% usually works very well. The resulting mesh is much lighter while still preserving the geometry accurately, making the following calculations significantly faster. Now let's repeat the process for the appendages. First, verify that each appendage is already a closed poly surface. The keel, bulb, and rudders should all be closed solids. And remember that they should slightly intersect the hull, as we've discussed in previous tutorials. Generate meshes for the appendages as well. Since these geometries are much simpler, a fairly coarse mesh is perfectly adequate. Here we don't need shrink wrap since the surfaces were already closed and anyway are much easier to close. Now select both the hull mesh and all the appendage meshes. Choose the mesh import mode from the drop-down menu and click load geometry. If we hide the original geometry, we can see our complete imported mesh. Let's generate the sections. As you can see, they are created almost instantly. And stability calculations become extremely fast. Everything runs in real time. From here, it's up to you to choose the level of accuracy you need. You can decrease the edge length to create a finer mesh, or use a less aggressive reduced mesh percentage if you need additional detail. From our experience, however, the workflow you've just seen is already more than sufficient to obtain excellent hydrostatic and stability results. In fact, this is essentially the same approach used by most commercial stability software. The difference is that in Rhino, you remain in complete control of the entire process. Thanks for watching, and see you in the next tutorial.